This is 1.7 part 2. So a compound inequality is an algebraic sentence containing two simple inequalities connected with and or. In other words, it looks something like this. X is greater than 3 or x is less than 2. It could look like that. It could look like x is greater than 3 and x is less than 2. That one actually doesn't work. We'll talk about that in a minute though. Or you could have 2 is less than x is less than or equal to 3. Even something like that would work. The solution to a compounded inequality can be an interval of real numbers that does not involve infinity, a bounded interval of real numbers. So that just means we stop both sides of our interval. So let's talk about some definitions. Your compound inequality, unless it's an or, will look like this. A is less than x is less than b, but a is just a number and b is just a number. And a must be less than b. And x, whatever it happens to be, has to be between a and b. So these are what bounded intervals look like. You can call this half open or half closed, half open or half closed, and then the two at the top, it's either completely open or completely closed. Notice how these have less than, parenthesis, 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 less than or equal to, less than or equal to, both have brackets, both have brackets. Here we have a less than or equal to and a less than. So we have a bracket first, then we have a parenthesis. Same thing on the graph. And here we have a less than, we have a less than or equal to. So we have a parenthesis first and then a bracket. Parenthesis, bracket. Now, just a couple of things to note. This one is not correct because 5 is not less than 3. The first one. The second one is not correct because you don't have two less than signs. This one is greater than. They both need to be less than. So that would be the same thing that's wrong with the third one. Remember that right there. This little symbol looks like a curvy E, means is an element of or belongs to. So now we're going to start talking about some sets. Let's talk about unions and intersections. This little symbol means union. This one means intersection. So what I want you to get out of this is union goes with or, and intersection goes with and. Union, or, intersection, and. And this is how I remember it. If you have a union, it's kind of like when two people get married and they throw all their stuff in one house. So what's yours is mine, what's mine is yours kind of thing. So what we want to do is take everything from both sets and throw them into the same set. So that's why I have married them there. For an intersection, you just intersect them. You only want what they have in common. So let's see, what exactly does that mean? Let's graph all of these sets on these three number lines. So we'll have set A, set B, and set C. 1 to 5, not including either point, would look, pretend like that's on a 5, would look something like that. And then we have 3 to 7, oops, that's not right. We include the 3, but we do not include the 7, so it looks like that. And then we have 6 to infinity, not including the 6. So 6 to infinity. So now we have those three sets graphed. So let's see what union and intersection means. A union B means take A and B, all the points that are in both of them, and throw them together into one set. Well, this goes from 1 to 5, and this goes from 3 to 7. So I guess the main question is, what happens at the end points? Is 1 included? Is 3 included? Is 5 included? And is 7 included? Because everything between 1 and 7 would be in this intersection. Everything that's in both of those sets will be in the union of them. So we would say it's going from 1 to 7 definitely. Is it including the 1? Well, 1 is not included here, and it's definitely not in this one. So, since it's not in either, we don't count it. 3 is included in this one, so it is included. 5 is not included in this one, but 5 is included in this one, so we count that one. Is 7 included? It's not in this interval because there's a parenthesis. It's definitely not in this one. So the union of A and B would look like that. So how about the intersection of A and B? The intersection is a little bit different. For intersection, you only want what they have in common. So what they have in common would be from here to here. Do they both share a 3? Yes and yes. So 3 will be included. Do they both share a 5? Well, this one has a 5, but this one does not. Since they don't share it, we don't include it. So we put it, but when we say we don't include it, we just put a parenthesis there. Okay, so here are those same intervals again. We have 1 to 5. We have 3 to 7. And 6 to infinity. What about the intersection of A and C? The intersection of A and C. Intersection means what they have in common. Do they have anything in common? This stops at 5 and this starts at 6. Does that include anything? It doesn't, right? So the intersection of A and C is completely empty. You would write it like that, which means empty set, or you would write it like this, which also means empty set. Never ever do this, because this is a set that includes a symbol that means empty set. So we would never want to do that one. Okay, how about the union of A and C? We want everything that's included in both sets. So we want all of these and we want all of these, whether or not they share anything. Well, we already determined that they don't share anything. So all you have to do is write both sets. We're going from 1 to 5, and we're going from 6 to infinity, and we're making a union out of them. So this would be the solution set for A union C. So what about trying one on your own? So pause the video, try it, and then start it back up again to see if you got it right. To review, A goes from 1 to 6, not inclusive. B goes from 4 to 9, including the 4, but not the 9. So A union B would be everything in both. So we're going from 1 to 9. We're not including the 1 because it's not in either, and we're not including the 9 because it's not in either. So then we have a intersection B. The intersection is what they have in common. This is what they have in common. Well, it goes like that. So we know it's going from 4 to 6, but we need to figure out if it's including in either of those. 4 is definitely included in this set. 4 is definitely included in this set. So we do include the 4. 6 is not here, so we don't even need to see if it's here, even though it is. We do not include the 6 because it is not in set A.